Hello everyone, my name is Joaquín, you can call me Kino, and I'm a flight dispatcher at Horizons, an airline focused on charter and VIP flights. For the next 25 minutes, I'll try my best to introduce you to the world of aviation, specifically to the flight operations sector, and most importantly, to show you what role can Python play in all of this. But first, allow me to start with a question. What is a flight dispatcher? This will be just for my knowledge, so don't worry, this is not high school. It's fine, I'm not going to ask nobody to come here to speak. Please raise your hand if you know what a flight dispatcher is. Okay, fair enough. Oh, it's not showing. Oh, okay. So I bet that some of you, maybe most of you, even though if you did not raise your hand, thought about this when I first asked the question. If this is the case and you thought about this, I kindly request you again to raise your hand. Okay. Well, unfortunately, this is not correct. The image depicts an air traffic controller. And although we share a common foundation and some knowledge, our jobs are completely different. For starters, we don't work at an airport. We work at a normal, boring office. But anyway, the question still remains, right? What is a flight dispatcher? To answer this question, I usually like to bring up another title that we receive. And although it's not as common, it helps explaining our job. Wait, excuse me. It should be, okay. So, another title that's not as common is flight planner. Because that's what we essentially do. We plan the flights. When the client requests a trip that they want to perform, it is our job to ensure that the flight will be not only efficient, but also, of course, safe. And for that, we need to do lots of things. First, we start by checking that both airports are suitable for the operation and for the type of aircraft that we are going to use. For this example, I chose a trip that we normally perform from Milan, the Malpensa airport in Italy, and Larnaca, located in Cyprus. So once we check that both airports are suitable for the operation, which is quite complicated at times, we need to select the most optimal route and also the most optimal flight level, which means the altitude. Then we calculate the fuel consumption and the fuel required for the operation, which are two different things. Then we select the alternate airports at destination. It is a common practice around the world to choose not only one, but two airports at destination. And it proves itself to be quite useful. A couple of weeks ago, we had a problem going to Madeira, an island from Portugal, close to the Canary Islands. And because the first alternate was also not suitable for the operation at that specific time, we had to divert to the second alternate. Following this line of thought, we also need to select the adequate airport throughout the route in case something goes wrong mid-flight, in case there's a depressurization of the cabin, an engine failure, a medical emergency concerning one of the passengers or the crew, or, as it happened just 5 days ago, we had a lightning strike, and it was quite dangerous, so we had to drift down to this closest adequate airport. Then we need to check the weather reports that look something like this. We need to check also the wind charts and the temperature. We need to check where the tropopause is in the crosswind section, the significant weather, if there's turbulences, icing conditions, thunderstorms, hail, and the notices to airmen or NOTAMs, which are reports about the status of each one of these airports. And it is longer than just these, these few lines. Well, and many other things. Believe me that if I had to list all the things that we need to do in a single day of work, it would take me the entire presentation. So, to this point, it's fun to see some of your faces because you keep looking at me like this. Yes, it is difficult, it is a bit overwhelming, but that's not it. There's something else that truly makes things chaotic, that makes things very difficult, and it is a big source of problems. I'm talking about the last minute changes. You might have planned everything accordingly, and you might have done a very good job. You're proud of your flight plan, even. But then, just an hour before the flight, more or less, something goes wrong, something happens, something changes. And depending on what has changed, you might be completely screwed. So, today I'm going to focus on a specific type of last-minute change because there's so many that it would be impossible for me to list all of them. But there's one specific change that's quite annoying at times. And it's actually you. Every single one of you. And also me. The passengers, of course. A sudden change in the number of passengers just before the flights can be devastating for the flight plan. If there's only one passenger more, everything's fine. If there's 20 or 80, as it happened a month ago, yeah, you're completely screwed, believe me. So, today, what I try to do is using Python, of course, to try not to solve this issue, but to avoid it from happening, to prevent, to plan beforehand, so we don't have to deal with these messy situations. The thing is that this issue of these sudden changes is more common than you might think at first, especially during the summer. But also that these can be predicted. Of course, this is not exact science, and we cannot expect the unexpected. We cannot see into the future. But it is true that these patterns varies depending on the day of the week, the time of the day, and if it is on a special occasion, for example, a football match. So, the script that I created was made using Pandas. Pandas is a very powerful library for data analysis. It has a tool called data frames, which are very useful to manipulate, while manipulating big chunks of data, and it's surprisingly easy. So it is a really good tool. Now, you see here that there's more libraries. There's datetime, matplotlib, and the infamous NumPy. This is because it turns out that using the information from our passengers and our company is extremely illegal. So, because I did not want to get fired nor sued, I had to come up with my own set of data. And for that, I used these other libraries. But keep in mind, the main script is only made with Pandas. Here you've got the data frame that I created. It's longer than just these 10 entries. It's got around 3,300. And as you can see, there's a lot of flights, a lot of information here. So I'll try to explain it in a bit of detail so you get to know exactly what this script does. So basically, we've got first the flight number. The flight number in aviation works a bit differently. But for now, let's just say that it's always connected to an airport of origin and an airport of destination. So for example, for this first flight in the 0 row, we've got Hotel Tango 0928 that will always depart from Tango Foxtrot November from Tenerife North, and will always arrive at Lima Papa Alpha at Gran Canarias Airport. If anyone's wondering, I used the NATO alphabet. It is widely used in aviation, and it is required in order to communicate properly with the passengers and the crew. So this Tango, Alpha, Mike, it's something that we need to know. And also, these letters are not random letters for each airport. This is what we call the IATA codes. They are official codes for every single airport around the world. Then we've got the date and the time of departure. Nothing, no mystery here. And the day of the week. The day of the week is a value that will go from 0 Monday to 6 Sunday. And finally, these last three columns, pax through, pax false, and pax total. At first glance, it's easy to see that pax total is the sum of these two previous values. And it is, in fact, true, but it's not the important thing here. The important thing is these two previous columns, pax through and pax false. So, pax is the short term that we use in aviation for passengers. You will see that in aviation, we love using acronyms, short terms, and codes. It's almost, honestly, kind of a fetish at this point. There's an official document from ICAO, the International Civil Aviation Organization, that gathers the most important acronyms, the most important acronyms and short terms. And it's got around 100 pages with a very tiny font, so there's a lot of them. Anyway, passengers through and passengers false. So while I was starting with this script, with this idea, I made myself a question. Was the ticket of each one of these passengers bought online? If the answer is yes, and the ticket was indeed bought online, this normally means that the ticket was bought before the flight. Might be months, might be days, might be just, might be weeks. But it is basically the information that we had while planning the flight. And if the answer is no, and the ticket was not bought online, the only option left is that this was bought at the airport, at the check-in counter. So you don't go to an airport to buy normally tickets that will depart in 2 months. So it's normally something that you do as a last-minute decision. And this is exactly what we're going to use today to try to predict these sudden increases in the number of passengers so we can get a heads up while planning the flights and we don't get into these messy situations because, believe me, it is very, very difficult to solve a sudden change of 80 passengers. Now, please don't worry. Do not be afraid of her. She's more afraid of you. Okay. You've got this in the repository that I created. To get this in detail, you can try and manipulate the code. But basically, what it will do is that it will get the filters that we want to apply to this previous data frame, and then we'll sort the values and get only the information that we want to know. Because, as you might have seen here, we've got a lot of flights that depart at different times and different dates and from different airports. So first, we need to filter this information and to get only those flights, for example, that depart from Tenerife North on Fridays, and see what's the pattern, what's the average of these sudden increases. So the code, basically what it's doing is that it will store this information, these filters, in items, in a list. Each one of these items is, as you can see here, will be the first element that is always a string. This string is the exact string that's the title of each one of these columns. So if I want to filter by the airport of origin, I need to write, it will write as a string, DEP, and then the second element will be the filter itself, the value that we want to filter by. In this case, it's a string that says TFN, but might be, as you can see on the other side, an integer. So once we run the script, we select these filters, we got this information stored in a list. And then we come to the core of the script, the most important part, that's also the shortest. It's this simple for loop. So what it's basically doing here is that for these I and j, it will display this filtered data frame that we've got, will only show those rows, those flights that match this specific criteria. So this I will match the title of the column, and the j will be this specific thing that we want to filter by. So we'll get something like this. That you see all these flights depart from Tenerife North and might arrive at Gran Canarias Airport or Barcelona, always on Friday. So once we've got this filtered information, then we can do whatever we want. I chose to apply a simple percentage function that will sum the number of passengers that are false passengers, sum the packs true, and divide packs false by packs true, and then multiply it by 100, a simple percentage. But the thing here is that we can apply whichever function we want, whichever thing that will get us important, relevant information about these sudden increases and stuff. But because I'm not a scientist, I'm not sure what else to apply. So this is something that anyone can try to modify or try to improve as you want. Because the important thing for me is just getting this filtered information and then getting this 36.39% of increase. Keep in mind that this is dividing the packs false by packs true, not by packs total, because we want to know the sudden increase compared to the information that we had, not the total, because we don't know what the total will be when we dispatch the flight. It sounds a bit stupid, but it works like this. So, now, okay, now, fine. You see, I'm not a programmer, so this was a really fun thing to do. I had a lot of fun, and I discovered a lot of things because Python is something that I used in the past, and is it's quite entertaining. It is interesting. But of course, anyone can try to improve these, to try to get it to work more efficiently, or whichever thing you want to do. But yeah, this is basically what I tried to do. Now, I think that you noticed that since the beginning of the presentation, I never tried to sugarcoat this. Indeed, the aviation industry is not perfect, is stressful, can be very annoying, and sometimes even frustrating. But believe me when I tell you this, the aviation industry is very, very rewarding. You're part of what makes people able to travel thousands of kilometers in just a few hours. It is astonishing what we've accomplished. And being part of what makes the world smaller and more connected means that we're making a better place. So yes, it is difficult, it is challenging, but there also lies the beauty of this job. You're constantly facing new problems, new situations, new scenarios, and you're constantly learning. It is also something that keeps your mind sharp, makes you able to deal with difficult situations in your day-to-day life. So it is something that I really, really appreciate. As a fun fact, when I started at this company not so long ago, my boss, so to speak, Eugenio, a really nice and kind soul, he came to my desk and he said, Joaquin, today I need you to work on your own. I need you to work alone because you need to know, you need to learn how to solve problems by yourself. So in case something goes very wrong, I'll try to help you. But try it first to do it by yourself. I'm sorry, I keep moving this. So he went back to his desk. I kept in mind, I started working. And within the last 30 minutes, I stumbled upon a problem that I did not know how to solve and that I had never seen before. And I was completely devastated. It was frustrating, and I felt defeated because he just told me just 30 minutes ago to try to solve this by myself, and I couldn't. So I went back to his desk, and I said, Eugenio, I'm so sorry, but I don't know what to do here. I'm sorry. I need you to help me. So, of course, he came back to my desk. He saw what the problem was, and immediately sat down next to me, looked at me in the eyes, and said, Joaquin, I don't know what the frick is going on, so I need you to help me, because I don't know what's happening. And guess what? In just an hour and a half, with a bit of a delay, we made it. I'm not going to bore you with the details, because it was something concerning the calculation of the fuel consumption, and it is something, as you might think, very sensitive. But we made it. So it is something that's very, very satisfying. Of course, I'm not only speaking about flight dispatchers or air traffic controllers or pilots. I'm talking about everyone else that's involved in aviation. From people working at the check-in counter and giving you the boarding passes, helping you to board the aircraft, to people that create, maintain, and develop the software that's used in aviation, not only the software that I used, these screenshots that I showed you with the routes, but also for everything else, from meteorologists to calculate to make the reports and try to predict the weather, to just making flight plans, or the things that are used to control the aircrafts during the flights. So what I want to say with this is that whichever your interest is, you might have find your own place in the aviation industry. And believe me, if I could made my own place in here, I bet that most of you wouldn't have any problems doing the same thing. So if you just think about this as something that might be a real possibility, just really tiny possibility, my job here today is done. Thank you so much for coming. I hope you enjoyed it as much as I did, especially thanks to the EuroPython crew for making this work and for making this such a great conference. And of course, if you have any questions, please do not hesitate to ask. And if you don't want to talk to me directly, you can send me an email to my business phone or through my LinkedIn page. And also, you've got the code if you want to test it in GitHub. Let me know if you have any concerns, and I'll try my best to answer all of you. Thank you very much.
Great, thank you so much. It was so fun to listen to you. Are there any questions? Yes.
Hiya, so first of all, thank you for making my vacation abroad possible, for making it happen. And I have a question, because most of these issues that you mentioned that affect your planning are very easy to understand by computers. Even this random passengers appearing, it's just numbers, right? We have fewer, we have more. But I wanted to ask about NOTAMs, because NOTAMs are very free-form. And do you literally have people sitting to read them and translate them into more like computer readable version, computer understandable version, because I can understand that anything can happen in NOTAMs, right?
Yes, everything can happen, from icing conditions to, in extreme case, bomb threats or something like that. So it's something very sensitive, and that can be done in very different ways. But the thing is that these mostly are sent by each one of these airports through a system that's, I believe it's called CETA. I'm not sure about this because this is something that concerns each one of these airports. And around the world, everyone makes their own decisions. But this is something that, this thing that I saw you before, let me get back to the 1 second. Yeah, you've got, there you go. So this is the raw information. There's some systems that will translate this into making a more readable and more easier way to understand what's going on. And of course, that's the version that we use. But this is something that's the raw version. So, and for example, my job, what I use is a simple iPad with a Jepsen charts. And this will translate this, and this, you see this here, that this goes on the right, SID-33. It's something related to the approach system. So once you approach the airport, it is something that, from my point of view, concerns only the pilot. I cannot do anything from my work to change it. It's something that they need to do. So this is information that I don't need while dispatching the flight. So this program will filter this information, will always give you the whole information, but will make it easier to read. So it is something that's, I hope this answers your question.
Okay, thank you. Thank you so much.
See you.
Hi, thank you for your talk as well. I was wondering why it was that having lots of last-minute passengers creates such big problems for you.
Okay, so basically what happens is that we need, as I told you, the fuel calculation is something very sensitive. So the more the aircraft weighs, the more fuel is required. And the more fuel is required, the more weight. The more weight, the more fuel. So it is quite a bit tricky to get this. So we need the information beforehand so we can plan things accordingly. If we get sudden passengers, we might have planned the consumption for an aircraft that will weigh a few thousand kilograms less. That means that if there's 80 more passengers more, you might not reach your destination with the fuel you've got on board. So it is very important to know this also with the luggage, to plan things accordingly so you know for sure that the aircraft will reach your destination. And the thing is that also, even if you do not you might have less fuel, but if you have more fuel than required, that's also another problem. If you exceed these structural limits regarding the weight of the aircraft, you might find yourself in a very dangerous situation because the aircraft needs to depart on a specific angle to avoid obstacles. If the aircraft weighs too much, it might not reach the specific climb rate. So you might have a problem. Also might affect the wings, the joints, and might create cracks. And even if it's not a problem while taking off, you might have problems while landing. The landing gear might not held all this impact and might explode. And it is something very dangerous also. So dealing with this is why sometimes, if you find in a situation that you see that you reached your destination and you have no luggage, and you say, why? No, it's why was my luggage on the ground? Why it was not on the aircraft? Because a flight dispatcher committed a mistake. So sorry about that. There's so other things, and the way to solve this problem is a bit more complicated. But yeah, that's basically it because of these structural limits.
Okay, thank you.
And thank you so much once again. I'm sorry we have to interrupt because we hit our time. But if you have any more questions, feel free to ask them in a break if you want. And once again, thank you so much for the great talk.
Thank you to you.